Well, hey everyone, good morning, and thanks for taking the time to join us for our webcast today. We really appreciate your time today. My name is Scott, and I'm here with my two colleagues, Ed and Surati.
Hi guys.
Good morning.
Yeah, we're here in Sunnyvale, California.
Thanks Scott, thanks for the question. So Ed and I have founded Applatix about 18 months back, and a lot of what we have enunciated in this best practice session comes from our own experience of using Amazon the last 18 months. More importantly, we have talked to several customers and have gleaned best practices from how they have used Amazon. So we kind of codified our own experiences of running Amazon, plus all the experiences that we've learned from the customers. Ed?
Yeah, definitely. So a lot of this is some basic things that Amazon themselves publish, but also some kind of pro tips that we've also learned along the way. So.
Okay, so let's get started with an agenda. So we're going to go through three basic elements here today. So account and user management. How do you monitor your spend, and how do you analyze your spend? And lastly, but most importantly, is how do you audit and how do you govern in Amazon, which is completely different from you have been using and doing on-prem. Let's start with the AWS account management, right? So again, if you sign up for AWS, you have an AWS account. Let's just call this a main account. This is the first account that everybody creates. And each account in Amazon has a root user, much as you have a root user and an admin on Linux. It's very similar to that.
Yeah, and we recommend that you treat your first account or your main account kind of differently from your other accounts, as you'll soon see.
Yeah. So now let's think about a few things that you want to do here. You have your main account and you have a root user for the main account. Root user account is the most important account. You cannot delete it, and you can also not restrict it using roles. So given those two constraints, you obviously want to take some precautions and best practices, like enable MFA, multi-factor authentication, right? That is we strongly recommend that. Do not create access keys for the root user account, because if you lose the access key or get stolen, then you pretty much compromise your whole AWS real estate.
Yeah, and there's only a few things that the root user account can do that other user accounts cannot do. So generally speaking, you don't want to use the root user account unless you absolutely have to.
Yeah, instead you create separate admin user accounts. Again, it goes without saying, just as a hygiene check, you don't want to be using root user account and don't want to be losing access to it. Second thing is, how do you secure your main AWS account? You also want to restrict the account so you're using it mostly for user management, roles management, consolidated billing, and access control. You don't want, we'll get into this later, you don't want to be creating users, IAM users on this account.
Yeah, and one of the things that this allows you to do is, on the main account, you can really provide users with very limited access to the account. So it allows you to basically greatly restrict the type of things users can do on the main account. And this is very important because we'll be setting up sub-accounts where actual work will be done.
Exactly.
And in those sub-accounts, just because someone has access to sub-account doesn't mean they can break into your main account. So it kind of isolates your main account from the accounts that you actually use for work.
Yep, I'm just showing a screen of users and MFA device. So you do want for every user that you create, activate MFA, right? So in order to restrict any user from just getting broken into. With MFA, the chances get decreased dramatically. So what we also recommend is you actually use sub accounts. I put sub in quote. These are like regular accounts, like your main account, except they're keyed off of your main account. They're hanging, if you will, off of the main account. Here I'm showing three different sub accounts, one for dev, one for QA, one for prod. Not necessarily in the same way you can set up. You can set up as you see fit in your organization. But the key thing is you want to create sub accounts and use those for actually doing the work.
Right. And each of those sub-accounts will in turn have their own root user account. And again, as with the main account, you really don't want to use the root user account for sub-accounts for anything if you can avoid it as well.
Exactly. So now, how do you go about setting up your users and policies? Now, before we get into that, here is a brief primer on some things in AWS IAM, which is Identity and Access Management.
Right. So since you're not going to be using your root account, that root user account, it means that you're going to actually create IAM users, on these accounts. And you can attach policies or permissions directly to users, but usually it's more convenient to create groups, which basically are a collection of policies, and then add users to particular groups. Especially if you have a large number of users, that's a much more convenient way of managing users. There's also something called rows, which again is a collection of policies. And then, interestingly enough, you use policies to control who can have access to which rows. So basically, policies control which users can assume which rows.
Yeah. So again, this is not meant to be a primer on a simple primer on IAM, but IAM is a lot more elaborate and has a lot more capabilities.
Yeah.
Right.
And a lot of people, when they see a policy document, are somehow put off by it because it's something unfamiliar. But really, once you start looking at it, you find it's really a problem more of familiarity than of, say, complexity. The policies themselves are not particularly complicated, it's just that you're not used to it. But once you write a few policy documents, you start getting the hang of it. So definitely would encourage you to, don't shy away from creating your own policies.
Okay, awesome. Now we've kind of gone through some of the capabilities of IAM. How do you kind of stitch these things together? So what we have found to be most practical and also most useful is to define all your IAM users in the main account. Do not create user accounts in each of the sub accounts. Create all of them in the main account. Like I'm showing here, I have Mary Combe, Bob Adams, Joe Smith. These are 3 different users, and they belong to different groups and have different policies attached to these groups.
Right. This also means that any access keys you create for users, particularly for programmatic access for scripting and other purposes, will only be created in the main account. And this will make it a lot easier to keep track of your users and access keys.
Okay, now then what you do is you actually create roles in your sub accounts. Like your dev, in this example I'm showing a dev has a role called dev admin role, and you map the policy to the role like we showed in the previous slide. And by definition in here, Mary Combe is now can assume the dev admin role in the dev account.
Right, and these roles that you're creating are cross-account roles, which means that they can be assumed from other accounts, primarily your main account. And then you're going to use policies on the main account to control which user is allowed to assume which role.
Yeah, so this way you have a neat distinction between your main account, which is just used for user management, and your sub accounts, where the actual work is being done, and you're controlling through policies and roles who can assume what in these sub accounts.
So can I just jump in here for a second? So to ask you guys, assuming from day one I take advice here and I set up my account structure, my sub account structure, roles and policies as like this. What are some of the benefits that are going to pay off over time for me?
So the first one that comes to mind is, if for whatever reason, say the AWS QA sub account is compromised, you cannot get back to any other accounts, right? You cordoned off a section of the AWS estate so that none of the other accounts gets affected. Number 2, each account has certain limitations on the resources, AWS resources. Given that, you kind of also, the QA performance work that they're doing is not going to affect your production resources, right? So you're basically setting up structures so that one account activity does not affect the other account and other account users.
Right. And you've also centralized all of your user management, as well as what privileges each user has into a single account, which is a lot easier to review, audit, and maintain.
Yeah, imagine having to create Mary Combe on all 3 different sub accounts. That would have been a nightmare to manage.
Can I ask the flip side of that question, which is, if if I've been doing this for a while and I didn't really set things up in this structure, is there anything I can do about it? Can I go retroactively and fix it or not?
Yes, you can fix it. It's a little bit more work. The two approaches would be, if you're running significant projects on each of these accounts already, you probably want to create a new account and treat that as your main account. So it would mean that you'd have to move users, teach users to log into this new main account now. Or if you have one of these accounts that really isn't being used for a lot of projects, you could convert that into a main account. So this is one of those things where it's definitely, if you kind of set things up appropriately to begin with, it's going to save a lot of hassles down the line.
Okay.
It's always difficult to retrain users to do something different.
Yeah.
Correct. So again, as you start out from the get-go, setting things up appropriately, so you have cordoned off accounts, cordoned off users would be a right way.
Okay, so it's a little more detail. So there's two main ways in which you can access AWS. You could access it through the console, so basically the GUI. You can also access it via APIs. We discussed how you can use policies to control access to your sub-accounts. So here's an example of how you would create a policy to enable users to assume roles in one of your sub-accounts. Basically, it's a very simple policy. You could just cut and paste this and just modify the account, and of course role name if you want to use a different role name. But if you attach this policy to any user or attach to a group that a user belongs to, then that user would be allowed to assume, in this case, like the dev role in whatever in account 1.
Correct. Okay.
And then once you do that, then you can go to the Switch Roles menu on the AWS console, and it will pop up this dialog where you could basically specify what account and what role you want to assume the roles. And assuming you have the appropriate policy attached to the user, that user will then be allowed to switch to that account. Now, once you do this once, the console will actually remember that you've done it. So next time you could just use a simple drop-down and the role will appear there. So you don't have to type this in over and over again.
Yeah, talk a bit about the MFA that you mentioned here, right?
Yeah, so this is a useful tip is when you create a cross-account role, you can specify that the user must have been authenticated by MFA in order to use that role. So if the user logs in without using MFA, they would not be allowed to use that role to switch to another account. So this is a convenient way to force your users to set up MFA if you want, since Amazon by default does not provide any option to require that users set up MFA.
Yeah, and as we talked about before, having MFA is actually a very good way, an extra layer of protection for accessing Amazon resources.
Yeah. Okay, so that's how you control console access. So how do you control API access? Again, you only want to create access keys for the main account. So the way you allow users to access your sub-accounts using APIs, given that the sub-accounts do not have user accounts or access keys for that user, is that you use the source profile directive in your Amazon profile, right? So you say the source profile is the main account. So that means that it's going to use the credentials from the main account to authenticate the user and then allow them to access, in this case, the dev account. Now, kind of a pro tip is that when you set this up, if you also require that an external ID is required, so here you say external ID equals whatever string you want. If you specify that, that ensures that this row, the dev API access row, can now only be used for API access. You cannot use it from the console to interactively switch rows. And the reason for that is when you switch rows in the console, there is no way to specify an external ID. It can only be specified when you're doing the API access. So this is a nice mechanism to ensure that this particular row is only used for API access, not for console access. Similarly, when you set up a policy for console access, if you require that the user it needs to be MFA authenticated, then that is a good way to discourage users from using that row for API access, since most users are not going to want to type in an MFA token every time they run a script.
That's a neat little clever way of forcing users to have API access to sub-accounts using different mechanism than console access to sub-accounts, right?
Yeah, absolutely. Yeah.
Great. So we talked about the best practices so far. We'll summarize in the next slide, but let's look at like few things that are not so good alternatives. You could have everything in one account, right? What that means is you don't have, as we discussed, coordinating of your resource utilization across accounts, and one could be stepping on each other's toes. You also don't have any visibility or accountability into each of these projects or groups that could have been set up with a sub-account of their own. Most importantly, some of the AWS resource limits are actually on a per account basis, right? And many of them can be increased, but we often find that some of them cannot be increased. By creating these sub-accounts and not using one account for everything, you're kind of sidestepping that issue a bit.
Yeah, and a very important limit that you really don't have control over is there's an API call limit per account. And Amazon doesn't really publish how that limit is determined or set. But it basically says that each account has a certain number of API calls they can make per hour or per minute or whatever the time unit is. And once you reach that limit, then additional API calls will simply fail. And presumably, if you have you're using more resources in one account than another, your limit is higher. But again, Amazon doesn't really specify that. If you are doing a lot of scripting and automation in AWS, it's pretty easy to hit that limit. So obviously, if you're using the same account for dev as well as production, not only do you have some major security issues there, but if your developers decide to experiment with something one day and they hit this API call limit, all of your production systems will be affected as well.
So yeah, the bottom line is you could use one account for everything, but practically it's next to impossible to account and also keep each groups into their own buckets and not hit these limits that AWS has. The other alternative is every user has a user account and access key on every account. Again, as you can see, this is a M by N type matrix with number of users and number of accounts that you have, right? It could get impossible to keep track of who has access to what. And more importantly, the possibility of a security access key leaking or getting out of other hands is dramatically increased. And we have heard horror stories of people checking in their access key into GitHub repos and waking up the next morning with a $6,000 bill on their Amazon account, right?
Right. This is probably every CIO's nightmare. Actually, it happens rather regularly. So much so that I heard that GitHub may be scanning regularly for these kind of access keys and sending email warnings or something like that.
Yeah, so I'm sure for every time you hit one of these things, the vendors are trying to proactively help the users. But you could actually avoid not getting into the scenario by setting up appropriate mechanisms. Okay, so let's just recap, right? What have we talked about? We talked about setting up your AWS main account and using that for all of your user management, group management, and policies. We talked about defining all of your users in the main account only. We talked about not using the root user account for anything other than a specialized operations that you want to do. We talked about setting up sub-accounts for actually getting all the work done and using the policies and roles mechanism for giving access to who has what access to the sub-accounts. What am I missing, Ed?
I think that was a pretty good summary.
Awesome. So let's then look at the second leg of the webinar that we talked about in the agenda, spend monitoring and analysis, right? This obviously is a big deal for anybody who's using AWS because you're spending by the hour. So you want to have a tight control and investigate changes in spending, especially when there is spikes in spending from what you had been observing historically.
And AWS provides a free tool. Basically, it's accessible from the AWS console. It's called AWS Cost Explorer. And as I mentioned, it's free. But there's some, it's like many AWS tools, it doesn't really have great usability. It does provide some useful information related to reserved instances. So if you're using reserved instances, you can use it to at least determine, how much benefit you're getting from the reserved instances. but it doesn't provide, for example, hourly granularity, only daily granularity. And when it does break out spending by line items, like how much are you spending on EC2 versus EBS or S3, it only breaks out like the first 5 items or so, and so oftentimes that is not enough items. You end up with this huge other category, and you're kind of left wondering what's in this other category. And kind of the default categorization that Amazon provides is not the most intuitive or the most useful. So again, like a lot of AWS features that are added, they kind of take it to the usability can definitely be better, which is why there's also a large collection of third-party applications that are available. Many of them for pay. Yep. For doing better like cost analysis.
Yeah, you could use like Claudia and Cloud Health. There's a number of these tools that actually give you information on cost accounting and how you're actually spending. Obviously, they're not free tools.
Guys, a question on the Cost Explorer spot instances as well. Can you monitor that?
Yes, I believe that it does. You can't determine like how much reserved instance and spot instance spending is used. It just does not present the information in a way though that makes like decision making really simple. So it also takes a bit of effort to figure out how to configure everything to get the report that you want. So like here's an example screenshot of Cost Explorer, right?
Yeah.
So you see that it only provides breakout for like the first 5 items. In this case, there aren't that many items, so this is not a big pain. But when you're looking at certain other categories like instance types, you could have a huge number of instance types. So just 5 items is usually not sufficient. And then just to get this kind of breakout, you have to fiddle with a lot of controls in order to get something that you find usable.
So it's basically it's free, but you have to spend a bit of time in kind of making it do what you want it to do. Right? That's what I'm hearing.
Yeah. Now once you create your account reports, it becomes a little bit useful. But again, it's free, but you also have to live with the limitations.
Okay. So like we talked about in the previous section, and use the main account for setting up your consolidated billing, right? So all of your sub-account billing is actually attached to your main account. So this is an example I'm showing here. That's the account that actually is the paying account here. And as you can see on the right-hand side here, all of the billing and paying is charged to the main account, and the sub-accounts just happen to be rolling up, if you will, into the paying account.
Right. And so in addition to the kind of convenience of centralizing all of your billing into one account, another advantage of this is that if you want to do monitoring, you only have to enable the AWS cost and usage reports on the main account. So you don't have to do it on each individual account.
Exactly. If you set up your structure like we discussed in the previous section, then the billing, which is the most important part of the cloud management, becomes much more simplified. How do you enable the cost and usage reports? And this is the screenshot in the Amazon console. The things that I want to draw your attention to is you want hourly reports, which is very granular, and also you want to include resource IDs.
The enablement resource IDs will allow you to do analysis in terms of how many reserved instances and so forth you need. Without the individual resource IDs, it'll be hard to tell how many instances are actually in use at any given point in time. Hourly granular is also nice. Now, one problem with enabling both hourly and resource IDs is that your billing reports file will be relatively large. Like even on a moderately sized system, it could be like a gigabyte or larger per month. So something to watch. Usually it's not a big problem. The S3 costs are not that high, but it's just something to keep in mind.
Okay, so let's talk about like the 2 kinds of billing report formats Amazon has. There is the detailed billing report, which is the old format, and there is a newer format called AWS cost and usage reports. The major distinction between the two is how reserved instance usage is actually reported, right? So the best practice recommendation from Amazon is to use the new format, which actually has a lot more details and also has specifically the RI usage and how it's reported.
Right.
Okay, so the
so this is kind of more of an advanced topic. Is once you have a relatively kind of more sophisticated systems, what you will probably want to do is to tag all of your resources, like instances and ELBs and so on. And typically you would tag them with tags indicating like who's using it or what project, what application, department, that kind of thing. And the big advantage of tagging it is first, you could search for these resources by tags from the console or through API. But also, you can enable that specific tags be included in your billing report. So now you'll be able to do spending analysis for using whatever tagged category that you want to use. Right? Now the challenge to doing this is that you have to systematically tag your resources.
Exactly.
Right? So like every time you deploy an instance, you're going to have to make sure appropriate tags are applied and so on. So this will typically mean that you have to use at least a little bit of automation to do it. So for example, if you're using something like Ansible, Chef, or Puppet to deploy instances, it's probably a good idea whenever you deploy an instance through that to have that service automatically tag your resources.
Yeah, so it does take a bit of an effort to not just tag once, but tag as you deploy and use resources in Amazon. So you do want to automate that process, but at the end of it, you actually get an extremely good view into what resources are being consumed and what are they being actually used for.
Right. Now, of course, a poor man's version of this is that you could just create a lot of accounts and then group your projects into accounts. So that kind of gives you a mechanism for doing more granular resource reporting, but as your usage increases, as you do more sophisticated things, there's probably no good alternative to tagging resources.
Yeah. Okay. So there are some limitations with AWS billing reports. The first one is even if you enable hourly granularity, like we mentioned a couple of screens back, the report that you get is only generated twice a day, right? Doesn't matter hourly granularity, you only get at 12-hour windows. So you may have to wait like 12, 14 hours before the report is generated, even at hourly granularity.
Right. And then for the last day of the month, Amazon takes some extra time to make sure all the resource usages are accounted for before generating a final report. So for the last day of the month, there's typically a 2 to 3 day delay before that report is generated. Both of these means that if you're in a hurry, like maybe someone started suddenly using a lot of instances somewhere, and you're kind of wondering how much is all of this costing you. It kind of creates some anxiety because you may have to wait 2 or 3 days before you actually get the billing report.
I guess one way to avoid the anxiety caused by the second bullet is to not use a lot of resources on the last day of the month.
Yes, that's one approach. Yeah, but in general, the billing report is not really a substitute for real-time resource usage monitoring. So
Correct.
Most people will probably want to use some combination of the two.
Yeah. So if we're using S3 is the simple storage service. The storage is being used throughout the day, but the attribution of the cost is to a particular hour in the day.
Yes.
You do have a proper accounting for how much you have spent on S3, but it is not linearly spread across when it is used. Rather, it is charged to a particular hour in the day.
Yeah, so this means that if you're looking at your spending on an hourly basis, you're going to see a big spike in for S3 usage on that hour where S3 gets built, even though you are in reality using S3 continuously throughout the day. The other kind of thing to watch out for is that any upfront payments you make for reserved instances, and typically you could get a 1 year or 3 year reserved instance, and you could decide whether to pay everything upfront or just partially upfront or nothing upfront at all. But anyways, any upfront payments you make are not amortized over time. The only thing that's reported over time is if you make a partial payment for a reserved instance, then the incremental additional payments you make as you over time is accounted for in the spending, but you won't see the upfront payment. So if you're only paying attention to these kind of daily spending reports, you may be lulled into a false sense that you're actually paying less for your reserved instances than you are, because the upfront payments are not amortized over time.
Do we suspect it's by design?
I won't make any comments on that. But,
Okay, so based on all of our own experiences at Applatix here, we've actually created a tool. We're calling it Claudia. It's a free AWS cost management tool.
Yeah, and we mainly created it initially for our own use because we wanted something we could use very quickly to just get a good overview of our own spending.
So what we have done is we have made it into an AMI where we are posting on Amazon Marketplace. We submitted it to Amazon for a posting, but this is a tool that we are making it free for simple analysis of your AWS bill. Here's a screenshot showing by services being your EC2 or EBS or S3, etc. Here's a second screenshot that shows by instance type, like your on-demand instance, spot instance, and reserved instance. It's extremely simple to use, and it just requires a consolidated billing that we recommended earlier that you set up using the newer format for your billing reports.
Yeah, so typically when you do analysis, you'll be filtering by various criteria like particular services or accounts, and then grouping by various things. So you'll be like iterating over filter group, filter group, filter group, and you could do multiple levels of this. So if you're interested in trying this out before we make the official release, please send us a message, on the chat app, and we'll shoot you a link. We'd love to get your early feedback. We just want a few early users to get some actual early feedback.
Yeah, exactly. If you are interested in trying this out, just send a message to Scott on the questions chat box, and we'd be happy to hook you up with access to this. Of course, we can also get more granular information on an application basis, a microservice container application basis using Applatix platform. I promise you this is the only time I talk about Applatix platform, but this gives you a second or more granular information of usage by service, by user, by project, by application, if you're actually deploying microservices on Applatix.
Yeah.
Okay, that kind of concludes the spend analysis section. So the last one is the audit and governance, which actually is extremely important for you to get right from the get-go. So let's dive into this.
Yeah, so the first advice is make sure that you enable CloudTrail on all of your accounts, because that will ensure that any destructive operations will be logged. And so if some permission on a security group or something changes, you can go to the console, issue some queries, and find out who made the change when, and what did they change, right? So without this, you will be basically flying blind, and you won't know what happened. It's also very useful for debugging kind of the API call limit problem, especially if you're doing a lot of automation. You may often hit API call limits. You could look at this log to see what API calls are using up your API call quota, and then from that kind of deduce what application or scripts may be making those things, and then be able to kind of scale back on your usage.
Yeah, again, in keeping with the previous advice on set up your sub accounts and do actual work there to minimize disruption and one team kind of stepping on each other's toes, you also want to enable CloudTrail on all of the sub accounts that you create, so that you actually can diagnose problems much more readily.
The other thing also, of course, is to use rows instead of access keys whenever possible, because keys can be leaked. They can also be unknown to the administrator, shared with other users, or even accidentally published on the internet somewhere. Whereas rows cannot be leaked or unknowingly shared. Also, in general, the rows are much easier to revoke because you could do it, always on a per user basis. Now, if you must use keys for a particular application, you want to make sure that the keys grant the minimum possible required permissions. Keys themselves cannot be associated specifically with policies. So in practice, what this means is that you're going to have to create a separate user account with the appropriate policies, and then create keys off of those user accounts.
Yeah, again, keep this in mind as we discussed before. You also want to create all of your users, groups, and policies on your main account. You don't want to be creating them on your sub accounts. You want to use the policies and the roles to associate users and access to the sub account and let them switch, log into the main account, then switch role into the sub accounts. Okay.
Okay, and then another thing that's kind of important, if you want to be able to route to your instances and other resources using private IP addresses, that is, you don't want to access them only through the internet, and of course you could set up very specific security group inbound rules to enforce security if you want to go through internet. But if you want to be able to access resources using private IP addresses, then it means that eventually you're gonna want to route between VPCs, and even VPCs in different accounts. So in order to make that simpler, you want to ensure that the subnets and VPCs you're creating have non-overlapping, CIDR blocks or IP address ranges, essentially. So creating a map of this, and a lot of people use a spreadsheet for maintaining this because Amazon doesn't really provide a convenient way to keep track of private IP addresses. So if you create one of these maps earlier on, it will make it a lot simpler and avoid you the pain of having to change CIDR blocks used by your existing VPCs and subnets.
Given that most people, including ourselves here, use like a wiki page or an Excel spreadsheet, the trick is not in creating the initial map, but continually updating it as you make changes, right? You cannot, it's not a one-time exercise. You have to make continual changes in order to keep the information up to date. And that is the trick here. You want to create it early, but you also want to continually make changes and keep up to date with the actual network configuration that you have.
Yeah.
Okay.
Okay, and then so just some basic things that are obvious. But just the one thing I'll point out is that if you can, it's very useful to be able to log all of your incoming and outgoing TCP connections from the internet. That way, if heaven forbid, someone breaks into one of your instances, they will often use it to launch attacks on other systems on the internet. So logging this information will make it a lot easier to determine, where did they break in from, what are they doing with your system, and just in general, if there is a break-in, make it a lot easier to detect that there was a break-in, because you'll suddenly see this instance accessing all kinds of random IP addresses on the internet. So
and doing port scans, and you may, if you are actually the software for regular vulnerability scanning, one thing that we have found ourselves is that if you are confined to a VPC and you're doing that in that VPC, you don't need approval. But if you want to do on a larger scale,
yeah, I don't want to make that a general thing. It really depends on how you do it.
Yeah,
but it's always a good idea to check what the requirements for doing vulnerability and penetration testing on your systems are, because in most cases you will need pre-approval from Amazon before doing this. Otherwise, they will think that you are it's an attack, and you will get a warning from Amazon.
Correct. So you don't want the warning to be issued from Amazon. Okay, so what are the key takeaways? We talked about how you should configure your accounts properly using sub-accounts and setting up your users in the main account and using roles and policies to associate access control. That is extremely critical. You also want to enable consolidated billing and reporting in the main account. If we set up the account structure properly, that's extremely simple. And it also enables you to track all of your billing in one central location. You also want to create the network map if you want to specifically use private IP addresses and CIDR blocks, so that you have a good sense of the network configuration. And more importantly, you have to keep them up to date by continually making changes as you change your network configuration. The last one is obviously you want to enable audit logging, CloudTrail, etc., and also perform regular security checks on your accounts, right? So this gives you a sense for whether there are any break-ins. If so, where the break-in is coming from. You can actually debug issues much more readily. That's all for this session. Scott?
Yeah, got a couple questions.
Any questions?
Yeah, so a couple questions. There's a new service from AWS called Organizations, or a new tool. for sub-accounts. Do you guys have any experience with that or have an opinion on that?
Oh, okay. Yes, AWS Organizations is a new feature that Amazon has come up with to make it easier to manage sub-accounts. We haven't used it ourselves, but based on what I've read about it, it does make it really easy to create an account and to set up consolidated billing for the account. And it also lets you kind of group these accounts into hierarchical groups. And it also lets you specify that like a particular account should only be allowed access to certain services. So like, if you don't want some project to have access to S3, you could say that, this account should never use SE services. But one thing that's really lacking is it doesn't provide kind of consolidated user management and management of policies and roles. So from that perspective, it's kind of hard to use this as like a general purpose AWS accounts and have kind of centralized management of users using these features. But it could be useful for creating maybe throwaway accounts if like a particular individual, like a developer operations person, just needs to do some experiments. It's very easy to create like a throwaway AWS account for them. They set up their users, manage it the way they want, and then when they're done, you just kind of delete the account. So it could be useful for kind of doing experiments.
Okay, great.
One more. The API limits problems that you described, is there any workaround for that or way to correct that?
How do you go about rectifying it? Right?
Yeah.
I think that's a great question.
There's no direct way to like modify the API call limits or anything. So really the only thing you can do is usually these limits are hit if you're doing a lot of automation. So you just have to figure out what you're doing in your automation that's generating like API calls and then kind of budget yourself basically. Try to make fewer API calls.
So it kind of like makes it extremely difficult given that Amazon does not publish these API limits, right? So you have to be extremely diligent.
Yeah, it makes planning a little more difficult.
Yeah.
Yeah, definitely.
And then reserved instances, you spoke about that very briefly. Do you recommend that, or is there any point of view you have?
Well, that's a huge
topic.
Chapter
topic in
topic
itself.
Yeah.
Really depends on like your how often you change instance types and all of this stuff. At Applatix, we tend not to use reserved instances a lot, mainly because we're constantly changing the set of instances types of instances we're using. So we prefer to use spot instances rather than reserved instances, just because we can structure our applications so that it doesn't matter if they're interrupted.
I'll do a shameless plug here of Applatix platform. Right? So we have some smarts in the platform that can actually leverage the spot instances for all of our dev work, right? So to keep it stable in the system.
And in general, I think as more people use microservices and containers, the applications are a lot easier to restart. So use of spot instances will probably increase, and they are cheaper than reserved instances. So you have three options. You can use on-demand, you could use reserved instances, or for a particular class of application, you could just use spot instances. We just like spot instances because it gives us more flexibility, and we set up our system so that you can do so.
Awesome.
Great.
Any other questions, Scott?
That's it. So
awesome.
Yeah, thank you everybody for your time and attention today. And we will have the slides posted by the end of the day today, and I'll also send you a follow-up email, most likely on Monday, with a video and the SlideShare link as well. And as Surati said, in 3 weeks we're going to do another webcast on more on cloud management and spend analysis, get deeper into this topic. And we hope you have a great day. Thank you very much.
Thank you all for joining.